Now in last video we discussed this working rules. That if u is a function of x and v is another function of x, then derivative of u plus v is derivative of u plus derivative of v with respect to x. And if here we put minus, then here there will be minus. So derivative of a sum or difference is equal to sum or difference of their individual derivatives for any constant k. K is any constant. Derivative of k into u, where u is a function of x, it is k into derivative of u with respect to x. Third working rule, derivative of u into v, derivative of product of two functions, u as it is, derivative of v plus v as it is, derivative of u. And fourth working rule was derivative of quotient is equal to derivative of u by v is, so here v is in denominator, so put here v square, then v as it is, derivative of numerator minus u as it is and derivative of v. So v square, v as it is, derivative of u minus u as it is, derivative of v. So these working rules already I discussed. Now formulas or derivatives, some standard derivatives. Derivative of x raised to n with respect to x is equal to n times x raised to n minus 1. Derivative of x raised to n is n times x raised to n minus 1. Derivative of any constant, this is free from x. Derivative of any constant is 0. Derivative of sin x, derivative of sin x is cos x. Derivative of cos x is minus sin x. Derivative of tan x, derivative of tan x is sec square x. Derivative of cot x is minus cos x square x. Derivative of sec x is sec x into tan x. Derivative of cosec x is minus cosec x into cot x. See, derivatives of all these functions can be obtained using first principle. From first principle or definition, these derivatives can be derived. So now, using these derivatives and these working rules, we are going to find derivative of given functions. Suppose question is find derivatives with respect to x. As for example, we want derivative of x cube minus 2x raised to 5 by 2 plus 7x minus 1. So derivative of x cube minus 2 into x raised to 5 by 2 plus 7x minus 1, it is equal to, say here, derivative of sum or difference is equal to sum or difference of individual derivatives. So first of all, I apply this rule. Derivative of sum or difference is sum or difference of individual derivatives. So derivative of x cube minus derivative of 2 into x raised to 5 by 2 plus derivative of 7x minus derivative of 1. So separate them by plus or minus. Derivative of sum or difference is equal to sum or difference of individual derivatives. Now look here. 2 is like k. 2 is like k. When any constant is given, then we take it outside. So this 2, it will come outside. So taking 2 outside, here we should put 2 into d by dx of x raised to 5 by 2. Similarly, 7 is like k. If any constant is multiplied, it is in multiplication with given function, then take that number outside. So here k, 7 is like k. So k I am taking out. So it will be 7 times d by dx of x. So this is 7 times d by dx of x. So this is equal to, now derivative of x raised to n is n times x raised to n minus 1. Derivative of x cube is 3x square minus 2 as it is. Now derivative of, here applying rule, x raised to n. Derivative of x raised to n is n times x raised to n minus 1. Derivative of x raised to n is n times x raised to n minus 1 plus 7 into derivative of x. X means x raised to 1. Derivative of x raised to 1 is 1 times x raised to 1 minus 1. So 1 times x raised to 0. X raised to 0 is 1. So 1 into 1 is 1. So derivative of x is 1. Derivative of x is 1 minus derivative of 1. Derivative of 1, constant, 1 is constant. Derivative of 1 is 0. Any constant here given. Suppose if you put here 4, so this should be 4, this should be 4. So derivative of 4 is 0. Derivative of every constant is 0. So this is equal to 3 times x square minus 5 into x raised to 3 by 2 plus 7 into 1 is 7. So this is required derivative. Then second question, we want derivative of x raised to minus 3 by 2 plus 2x plus 5 into sin x. We want derivative of this function. So derivative of x raised to minus 3 by 2 plus 2x plus 5 into sin x. Here we want derivative of u into v. Here we obtain derivative of sum or difference. Here we want a derivative of product. So consider this part as u, this part as v. U into v. So derivative of u into v is by this rule. U as it is, derivative of v, plus v as it is, derivative of u. So here this is u. U as it is, derivative of v, plus v as it is, derivative of u. Derivative of u into v is u as it is, derivative of v, plus v as it is, derivative of u. So that is application of this working rule. Now this is constant. This we keep as it is. Derivative of sin x is, derivative of sin x is cos x. Derivative of sin x is cos x, plus sin x as it is. Now derivative of this function. So as did here, from this step, if no any mistake, then you can direct put such derivatives. See, derivative of x cube is 3x square minus 2 into derivative of x raised to 5 by 2 is 2 times. You can join here. Derivative of x cube is 3x square minus 2 as it is. Derivative of x raised to 5 by 2 is 5 by 2 into x raised to 5 by 2 minus 1, plus derivative of 7x is 7 into 1, then 0. So direct we can put if derivatives if function is simple. Now here this is simple. So derivative of x raised to n is n times x raised to n minus 1. So minus 3 by 2 minus 1. So minus 5 by 2, plus derivative of 2x is 2 into 1. Derivative of x is 1. So derivative of 2x is 2, plus derivative of 5 is 0. So no need to put 0. So this is required derivative. Then third question, obtain derivative of 1 minus 10x upon 1 plus cot x, or let me take x plus cot x. We want a derivative of this function. So say here d by dx of 1 minus tan x upon x plus cot x. We want a derivative of u by v. U by v. So applying this rule u by v, we consider this numerator as u, denominator as v. Then by this rule, d by dx of u by v is v square as it is. So here v square as it is. V square as it is. Denominator we put v square. Then here v as it is. Then whatever you put here, same number put here, x plus cot x. So v square, then v, same number. Then into derivative of numerator, into derivative of numerator, minus u as it is, derivative of v, minus u as it is, into derivative of v. So that is application of this working rule. Derivative of u by v is v square, v as it is derivative of u, minus u as it is derivative of v. So this is equal to here x plus cot x whole square. This is x plus cot x into, now derivative of 1 is constant, derivative of constant is 0, minus derivative of 10x, derivative of 10x is sec square x, derivative of 10x is sec square x, so I keep here sec square x, minus 1 minus 10x into this number as it is. Now derivative of x, derivative of x is 1, then plus, so plus cot x. So derivative of cot x is, derivative of cot x is minus cos x square x. So minus cos x square x. Derivative of sum is sum of individual derivatives. So derivative of x plus derivative of cot x. So this is equal to x plus cot x whole square. This is minus x square x. So x plus cot x into minus x square x. So that is minus sec square x into x plus cot x. Here let me expand this expression. X into minus x square x, so minus x into sec square x minus cot x into sec square x minus 1 minus cos square, that is plus cos x square x, minus 10x into 1 minus minus plus 10x, then again minus 10x into minus cos x square x, so plus 10x into cos x square x into minus 1, so minus 10x into cos x square x. So this is required derivative. This is required derivative. Now find derivative of these functions. Say here d by dx of x raised to 5 into 3 minus 6 into x raised to minus 9. Differentiating this with respect to x. Say here we can do by these two ways. First of all, the first way is multiply this bracket. So 3 into x raised to 5 minus 6 into x raised to 6 into x raised to 5 into x raised to minus 9. 5 minus 9, that is minus 4. So it's a simple form. Now differentiating, see 3 is constant keep inside, 3 into d by dx of x raised to 5 minus 6 is constant, in multiplication keep inside derivative of this function. So 3 into derivative of x raised to 5 is 5 times x raised to 4 minus 6 into derivative of x raised to minus 4 is minus 4 times x raised to minus 5. So this is 15 into x raised to 4 plus 24 into x raised to minus 5. That is required derivative. Or you can also differentiate this by u into v, d by dx of x raised to 5 into 3 minus 6 into x raised to minus 9. Consider this as u, this as v. So u as it is derivative of v plus v as it is derivative of u. U as it is derivative of v plus v as it is derivative of u. So that is x raised to 5 into derivative of 3 is 0 minus 6 into derivative of x raised to minus 9 minus 9 times x raised to minus 10. So minus 9 times x raised to minus 10. Here I am changing pattern of bracket. So derivative of 3 is 0 minus 6 times derivative of x raised to minus 9 is minus 9 times x raised to minus 10 plus 3 minus 6 into x raised to minus 9 as it is. Derivative of x raised to 5 is 5 into x raised to 4. So simplifying this, x raised to 5 into, this will be 9 into 6, 54 x raised to minus 10 plus 15 x raised to 4 minus 30 x raised to minus 5. So now joining this is equal to 54 into x raised to minus 5, 54 into x raised to minus 5 plus 15 into x raised to 4 plus 15 into x raised to 4 minus 30 into x raised to minus 5. So 54 minus 30, that is 24 x raised to minus 5 plus 15 into x raised to 4. So this is same answer which we have obtained here. So can be done by any way, by this way or do by this way. Now here d by dx of 2 upon x plus 1 minus x square upon 3x minus 1. Now derivative of difference is equal to difference of their individual derivatives. So it is d by dx of 2 upon x plus 1 minus d by dx of x square upon 3x minus 1. Differentiate individually by working rule. Derivative of u minus v is derivative of u minus derivative of v. Now 2 upon x plus 1, this is like u by v. Derivative of u by v, that is v square. v square, v as it is, derivative of u minus u as it is, derivative of v. Then minus, now for this expression, derivative of u by v, that is v square. See, once again application of u by v in this second term, v square, u by v, so v square, v as it is, v as it is, derivative of u minus u as it is, derivative of v. So that is equal to, now putting values, x upon x plus 1 whole square, x plus 1 into derivative of 2 is 0 minus 2 into derivative of x plus 1, derivative of x is 1 and derivative of 1 is 0. So derivative of x plus 1 is 1 minus 3x minus 1 whole square, 3x minus 1 into derivative of x square is 2x minus x square as it is, derivative of 3x minus 1, so derivative of 3x is 3 minus derivative of 1 is 0. So this is equal to, now see, x plus 1 into 0 is 0, this will be minus 2, so minus 2 by x plus 1 whole square minus, here simplifying this, 3x into 2x is 6x square minus 2x, this will be minus 3x square upon 3x minus 1 whole square. So minus 2 upon x plus 1 whole square minus 6x square minus 3x square is 3x square minus 2x upon 3x minus 1 whole square. So this is required derivative. Now see here in this question, derivative of x cube into sec x minus 5 into cosec x. We want this derivative. Derivative of u minus v. Derivative of u minus v is derivative of u minus derivative of v. Then here we use rule u into v. So u as it is, derivative of v, u as it is, derivative of v plus v as it is, derivative of u minus 5 as it is. Say 5 is like k, derivative of k into u, so k keep as it is, and derivative of cosec x. So that is x cube into derivative of sec x is sec x into tan x plus sec x into derivative of x cube is 3x square minus 5 into derivative of cosec x is minus cosec x into cot x. Derivative of cosec x is minus cosec x into cot x. Derivative of sec x is sec x into tan x. So this is x cube into sec x into tan x plus 3x square into sec x. This is plus 5 into cosec x into cot x. So that is required derivative. Derivative of ax square plus b whole square. Here we want derivative of ax square plus b whole square. This can be expressed as ax square plus b into ax square plus b whole square. Now here we can apply rule u into v. U as it is, derivative of v plus v as it is, derivative of u. So that is ax square plus b into, now derivative of ax square plus b, so a keep as it is, a is constant in multiplication, so keep as it is, and derivative of x square is 2x plus derivative of b is constant, here a and b are constants. So a as it is, derivative of x square is 2x plus derivative of b is 0 plus ax square plus b as it is, again derivative of ax square plus b a into 2x plus 0. So this is 2ax into ax square plus b and same 2ax into ax square plus b. So this is 4 times ax into ax square plus b. So that is required derivative. Now here d by dx of x raised to n minus a raised to n upon x minus a. We want a derivative of this function. Here a is constant. This is like u, this is v, u by v. Applying a rule for u by v. So by rule, derivative of u by v is v square, v as it is, derivative of u minus u as it is, derivative of v. V square, v as it is, derivative of u minus u as it is, derivative of v. So that is x minus a whole square. Now here x minus a into, now say look here, derivative of x raised to n is n times x raised to n minus 1. Derivative of a raised to n, see a is constant, n is also constant, a and n both are constants, so this is constant. So derivative of constant is 0. Whenever we differentiate with respect to x, if any term or number which is free from x, that is constant. So this is constant, so its derivative is 0 minus x raised to n minus a raised to n into, derivative of x is 1 minus derivative of constant is 0. So this is x minus a into n times x raised to n minus 1, n times x raised to n minus 1 into x minus a, minus this is x raised to n minus a raised to n upon x minus a whole square. So simplifying this, multiplying this number with x, so n into x raised to n minus 1 into x is x raised to n minus n a into x raised to n minus 1 minus x raised to n plus a raised to n upon x minus a whole square. Now from these two numbers x raised to n common, so n minus 1 into x raised to n minus n times a into x raised to n minus 1 plus a raised to n upon x minus a whole square. Now look here, derivative of sec x minus 1 upon sec x plus 1, again u by v, so v square, derivative of u by v is, put here v square, then v as it is, derivative of u into derivative of u, then minus u as it is, derivative of v, v square, v as it is, derivative of u, minus u as it is, derivative of v. That is, here sec x plus 1 whole square as it is, sec x plus 1 into derivative of sec x is sec x into tan x minus derivative of 1 is 0, so no need to put 0. So derivative of sec x minus 1 is sec x into tan x minus sec x minus 1 as it is, and again derivative of sec x is sec x into tan x and derivative of 1 is 0, so its derivative is sec x into tan x. Now we are sec x into tan x common into, here what is left, sec x plus 1 is left, here minus sec x minus 1, that is minus sec x plus 1 upon sec x plus 1 whole square. So this is cancelled, so 1 plus 1 is 2, 2 into sec x into tan x upon sec x plus 1 whole square. So this is required derivative. Here fx is x raised to 100 upon 100 plus x raised to 99 upon 99 plus up to x square by 2 plus x plus 1. Now differentiating with respect to x, f dash x is, this is 1 by 100, it is constant, so 1 by 100 keep inside, derivative of x raised to 100 is 100 into x raised to 99 plus, here 1 by 99 keep as it is, derivative of x raised to 99 is 99 into x raised to 98. So continuing this procedure, here 1 by 2 as it is, derivative of x square is 2x plus derivative of x is 1 plus derivative of 1 is 0. So f dash x is x raised to 99 plus x raised to 98 plus up to x plus 1. Now We want to prove f dash of 1 is 100 into f dash of 0. So putting x equal to 1, for x equal to 1, putting here 1, f dash of 1 is 1 raised to 99 plus 1 raised to 98 plus up to 1 plus 1. This is 1 raised to 1. It was x raised to 1. So say here these are 99 times 1. This is 1 plus 1 plus 1. This total is 99 and plus 1. So total is 100. F dash of 1 is 100. Now we are putting x equal to 0. Putting x 0 here, f dash of 0 is 0 raised to 99 is 0 plus 0 raised to 98 is 0 plus up to 0 raised to 1 is 0 plus 1. So f dash of 0 is 1. F dash of 0 is 1, multiplying this on both the sides by 100. So f dash of 0 into 100 is 100. This was value of f dash of 1. This is 100 into f dash of 0. So from 1 and 2, f dash of 1 is 100 times f dash of 0. So result is proved. Now here d by dx of u by v, d by dx of px square plus qx plus r upon ax plus b. We want a derivative of u by v. So considering this as u and this as v, so this is v square, v as it is, derivative of u minus u as it is into derivative of v, that is d by dx of ax plus b. V square, v as it is, derivative of u, minus u as it is, derivative of v. So application of working rule for derivative of u upon v. So this is equal to here ax plus b whole square, ax plus b into, now derivative of this function p as it is, p is constant, derivative of x square is 2x, so p into 2x, that is 2px, plus derivative of qx is q into 1, derivative of r is 0, minus px square plus qx plus r into derivative of ax plus b. A is constant, derivative of x is 1, so a as it is into 1, that is a plus 0. So this is now multiplying this in the numerator, ax into 2px, that is 2apx square plus 2bpx multiplied by ax multiplied by b, or first of all we multiply ax by q, so ax q, then plus 2bpx plus bq, this side minus pax square, apx square minus aqx minus ar upon ax plus b whole square Now 2apx square minus apx square, that is apx square. This is aqx, this is minus aqx. Now 2bpx plus 2bpx plus bq minus ar upon ax plus b whole square. So this is required derivative. We want a derivative of this function d by dx of sine of x plus a upon cos x. So this is equal to applying u by v. Here v square, v as it is, derivative of u minus u as it is, derivative of v. V square, v as it is, derivative of u minus u as it is, derivative of v. That is cos square x, cos x into, now see here we want a derivative of sine of x plus a. We have formula for sine x. We know that derivative of sine x is cos x. We don't have for sine of x plus a. We are having 6 or 7 basic formulas. Derivative of sine x is cos x, derivative of cos x is minus sine x. So x must be there when you take differentiation with respect to x. So here to obtain derivative of this function, what we do, first of all I keep formula for sine of x plus a. Here a is constant. Remember a, b, these are constants in these questions. A, b, c, p, q, r, these symbols are constants. Only x is a variable. So sine of x plus a, so formula for sine of x plus a is sine x cos a plus cos x sine a. Derivative of sine of x plus a is sine x cos a plus cos x sine a. Before differentiating this function, we have to put formula. This number sine of x plus a, and here derivative of cos x, that we know derivative of cos x is minus sine x. Still here work is due, work of differentiation. Now see, here cos x into, now see this is constant, a is constant, so cos a is constant. Sine a, this is constant, these numbers are constants. Sin x and sin a and cos a are constants, so constants we keep inside. So here cos a is constant, so constant inside, it is like k. Derivative of k into fx is k into derivative of fx plus derivative of k into fx is k into derivative of fx. Constant k we take outside. If it is connected in multiplication, this is minus minus plus sine of x plus a into sine x. Now here cos x into, this is cos a into, now derivative of sine x is cos x plus sine a into derivative of cos x is minus sin x. Derivative of sin x is cos x, derivative of cos x is minus sin x. We keep this in bracket. Plus sin of x plus a into sin x upon cos square x. Now this is cos x into, now look, it is cos x cos a. Now I am rearranging cos x cos a minus sin x sin a. Rearrange sin x sin a plus sin of x plus a into sin x upon cos square x. Now see what is it? This is cos alpha cos beta minus sin alpha sin beta, cos of alpha plus beta. This is cos of x plus a. It is cos of x plus a. This is cos of x plus a into cos x plus sin of x plus a into sin x upon cos square x. Cos alpha cos beta minus sin alpha sin beta is cos of alpha plus beta. Once again, say again cos alpha cos beta plus sin alpha sin beta. Cos alpha cos beta plus sin alpha sin beta. This is like alpha, this is like beta. So cos alpha cos beta plus sin alpha sin beta is cos of alpha minus beta upon cos square x. So this is cos a upon cos square x. That is cos a into sec square x. This is required derivative. Now here d by dx of x square into cos pi by 4 upon sin x. We know value of cos pi by 4. We put cos pi by 4 1 by root 2. So d by dx of x square into, this is 1 by root 2. So put root 2 here in denominator. Now derivative of u by v. So v square v as it is derivative of u minus u as it is derivative of v square v as it is derivative of u minus u as it is derivative of v. So this is equal to, this is then 2 sin square x, here root 2 sin x into derivative of x square is 2x minus x square into, this is root 2 into, root 2 is constant, root 2 keep as it is, and derivative of sin x is cos x. So here 2 root 2 into x common, 2 root 2x common. So what is left inside bracket? Sin x minus, not 2, only root 2 is common. Root 2 is common and x is common. Root 2 and x common. So what is left here? 2 sin x minus x cos x upon 2 sin square x. Again here root 2 into root 2 is 2. So this is x into 2 sin x minus x cos x upon root 2 into sine square x. So that is required derivative. So application of u by v. If you keep in this calculation, if you keep cos pi by 4 as it is in this calculation, then answer can be in different form.